Hey everybody, we are looking at this problem called backspace string compare. It's an easy problem on LeetCode, but the optimized solution for this problem should be considered a medium problem. Now let's take a look at the problem. Given two strings, S and T, return true if they are equal when both are typed in empty text editors. Hash means backspace character. Now what does it mean? Let's look at the example. A, B, hash, C. We are typing this in an empty editor. Hash is a backspace, which means we type A, we type B. Hash is a backspace, which means we delete this and then we type C. So the overall output is AC. What happens in this case? A, D, hash, and C. We type A, we type D, and hash is a backspace. D is deleted, and then we have C. So the overall is AC. Are these two equal? Yes, they are equal, which means we are supposed to return true. Similarly, this and over here, this. The output for this would be just C, and on the other hand, we have B, they are not equal. So, this is what we are supposed to find out if they are equal or not. We have a very easy solution to this problem. We can use a stack. Every time we have an element which is not hash, basically an alphabet, we put that variable in a stack. Every time we have a hash, we pop the element from the stack. Let's take a look. For this input, we have AB, hash would pop B, and then we have C. For the other side, we have AD, D is popped, and then we have C. These two stacks are equal. So this is very easy to solve. Over here, we are using extra space. For this, worst case of O of n, for this, worst case of O of n. Can we do better? Can we take O of 1 space? And this is what the question is asking in the follow-up, which is, can you take O of 1 space and O of n time? How do we do that? Let's assume we have a string like this, and we need to find out the effective string, which we can see over here and say it is A, B, these two will not be considered, and then E. This would be the effective string. Now, how do we find out the effective string? If we can find it out for both, we can make that comparison without using extra space. So let's look at it this way. What if I start from the end? I see a hash over here. So can I say if I have one hash, the element immediately after that, if it's an alphabet, I can ignore it? I think yes. I can ignore this F. Then I can go to E. There is no hash anymore. That hash was used to ignore F. Now I'm on E. So I can consider E as a valid character. This would be part of my output. Then I go to hash and I say, okay, I have another backspace. Can I go forward and see what do we have here? It's another backspace. So we have two backspaces. So can I say that if I have two backspaces over here, I can ignore these two alphabets? Yes, I can ignore these, which means now I can be over here. Do I do I have any other backspaces left? And the answer is no. Those backspaces are used. So now I have B and I have A, which means if I go from the end to the beginning, I can skip elements on the basis of the number of hash we have, and I can get the effective string. And this is the concept which we would use to solve this problem in O of one space. Let's try to understand this problem better by looking at the code. So I am here in the code editor. I am given this function backspace compare, and it receives two parameters s and t. These are the two strings given to us. I need to traverse through the string and compute their effective value. So to traverse the string, let's keep two pointers I and j. I would be assigned to length of s minus 1. J would be assigned to the index length of t and minus 1. I want to traverse through this entire string, and I'm starting from the end to the beginning as we discussed in the explanation. So while I is greater than or equal to 0 or j is greater than or equal to 0, we are doing an or condition over here because we want to still traverse if one of the string ends before the other. They may have effective length similar, but their string length in S and T might be very different. So we are doing an or over here that we want to keep traversing even if one of them ends. The next thing, as we discussed in the explanation, since I start from the end, every time I need to find out what the next pointer on the string would be. For example, if I have a string like A, B, C, hash E, I'm starting from over here, but then I want to find out what the next string should be. Should it be this? Should it be this? Or should it be this? We can see over here that the next would be actually this. C would not even be considered, and here hash would not even be considered. It's not a valid character. So if this was my string and I input this index, then the next valid pointer to the string would be this. And I need to find this one out. Let's see how we do that. So let's say I have this variable next s assigned to a function which I have not defined yet. Let's call it get next char. This would give me an index. I need to pass the index we are at right now and the overall string s. This function needs to look at the string. Very similarly, we can say next t. This is the index of the location where the next valid value in the t string would be present. Self dot get next char, and I can pass j and t in this case. We have not defined this function yet. This would be a char. So what if I have, let's suppose this function works. What if I have next t and next s and next t, which means I have two values. Let's define this function get next char. It has a position from where we start, and it has the overall string. Let's call it st. Let's call it s. Next, I need to keep account of the number of backspaces I encounter. So let me say that initially I have the number of backspace equals to 0. Then I need to start from a position. Let's say I equals to position. This is the position that we have supplied. We start from over here. We start traversing from over here. And how long can we traverse? We can traverse the entire string. So while I is greater than or equal to 0, we can traverse this string. So what if s of I turn out to be a hash, which means we encountered a backspace. If we encountered a backspace, what do? We increase the number of backspaces we have. At the same time, once we have received a backspace, we can say, okay, let's reduce the value of I by 1. Let's look at the next element. Else if we do not have a backspace, which means we have a character. But there are two cases in case we get a character. What if there is a backspace already in the count? In that case, we are supposed to reject that character. So we can do count greater than 0. If there is a backspace, we are supposed to reject this character. So we can reject it like this. At the same time, we need to decrease the number of backspaces. We use this backspace. What if there is no backspace at all? It's not a hash, which means it's not a backspace. There are no previous backspaces. So we can write an else condition, which means this is a valid character. We can over here say, you know what, break out of this while loop and just return j from over here. So this function over here can give us the next valid character. Now we need to handle different cases for next s and next t. So what can be the different cases? Let's say we have strings like these. The next s or next t can be something like, they both ended. If they both ended and they never returned false from any of these places, in that case, we can say that let's return true, that we have equal strings, they both ended together. Or else we may have something like one is over here and the other is over here, which means one ended and the other did not. That should be an invalid case because the S and T may have different lengths, but their effective length should be similar. If it is not, if one ended and the other did not, that would be a false case. Or they may be something like this, or they may be something like this or this. In these cases, we need to check what their respective values are. So CA, we would say, okay, it is invalid. For BB, we would say, okay, it is valid. So we have three cases. Both ended, one of them ended, or both did not end. So let's write these three cases. If next S is less than 0 and next T is also less than 0, in this case, we can return true. Else if next S is less than 0 or next T is less than 0, one of them is less than 0, let's return false. Otherwise, let's just check. Since we are returning from over here, I'm not going to write an else condition. I can say this is the else condition. The value at these positions, which means these are valid values. The values at these positions, if they do not match, in that case, let's return false right away. If they match, let's check further. They may have a mismatch in future. After that, we are done with these conditions. We checked if they are valid or not. Let's go forward in the string and do more checking. Let's move forward I equals to next of s minus 1, j equals to next of t minus 1, and we are done with this while loop. It would execute until j and I, one of them is present, and we can return over here true. Let's run this. So it's saying we don't have a j because it's actually I. That was a typo. Okay, it's passing. Let's submit it. We have a solution to this problem. The one thing to note, it is not an easy problem. If you solve it using stack, it's easy. But if you solve the follow-up, it would be a medium problem.